All right, let's get started. Hello, everyone. It's a big room. Thanks for coming out. My name is Noah. I'm from New York. I work for a startup called Teachers Pay Teachers. We're an online marketplace for teachers to sell educational materials to each other. So we're like Etsy for teachers, if that makes sense. So before I get started, could I just get a show of hands? Like who here has a tester title or a tester role? Okay, and then how about ops, like systems operations? Anybody? A couple of people. Okay, that's about what I thought. And just what about infosec, security? Okay, that's what I thought. Okay, part of the reason I ask is just curiosity, but part of the reason I ask is because what I've found myself doing in terms of technical testing in the last few years is transferring knowledge from the ops and the infosec world to the testing world. Some of these tools that I'm going to talk about today are tools that systems operations would ask about, like in an interview. But for developers, for QA, for software testers, we don't get to learn about these tools. Or maybe we do. I would love to, if these are familiar to you, I would love to hear about that afterward. So I'm going to talk about oracles. Is the term oracle something that people have run into before? Is that familiar to anyone? A few people. Okay. So oracle is a term that actually is a testing term, but it isn't used so much lately, and I think that that's too bad. So in mythology, an oracle, like the oracle at Delphi, was a powerful mystic who could see into the future. She was the source of knowledge and the arbiter of fate. So in software testing, an oracle is a source of knowledge. An oracle is just a fancy term for anything that you refer to help you understand what your test did. Because there's an interesting phenomenon that I'm sure many of you have seen, where this sort of cargo cult can develop around especially automated tests, especially a large number of automated tests running in a CI system. I first encountered this when I joined Etsy back in 2010. There was just a lot of religion around the tests, and when you actually started to apply some ethnography and some scientific method and some just basic asking questions, it was obvious that no one really knew what Etsy's test did. And I think that the thing that I'm probably the most notorious for, if you ask people, is for ripping out all of Etsy's functional tests and replacing them. Simply because there were no oracles. There was no way we could run hundreds of tests, but there was no way to tell what they meant anymore. We had lost the sense of our tests. So what I'm going to propose here is that something that I bet won't be very foreign to any of you, but that we apply the scientific method when testing, rather than either guessing or hoping or pursuing a specific narrative. And by pursuing a specific narrative, I just mean an example of a specific narrative would be, we will ship the feature in 3 weeks. That's a narrative. That's a story about us and our team and what we're going to do, and it has a beginning, a middle, and an end, and a story arc. So it's a myth about how we're going to ship. The way that I prefer to work, and the way that I think tests are really helpful, is not in creating a narrative, not in creating a story about what we're going to do, but rather in giving us data day to day about what we can do and allowing us to reflect on what we have done. This, I think, is the whole point of testing. So we all know in this room, I'm sure, that a 0 response code from the test means everything is good, and a non-zero response code means something is bad. Nobody else outside of testing knows what that means. No executive ever said the phrase 0 response code. So there's these gradients of understanding and knowledge around our tests, and as the people closest to the tests, we're responsible for being arbiters, or better, providing systems that can be arbiters of that knowledge, oracles. So these are questions that I love to ask people who have big suites of tests and no oracles. And this is my big map of theory here. So we have this sort of Venn diagram here of this is what our knowledge looks like when we're testing software or when we're testing anything. So there's this infinite area of unknown unknowns, right? And there's this infinite area of known unknowns that we can, so by known unknowns, I mean things we can potentially know, things that tests could potentially tell us. And then there's this whole area over here of things that tests can never tell us. There's this theoretically, at least, infinite area of knowledge, and then there's this great area down here, this infinite number of things that are testable. And then in here, you've got monitoring and deterministic tests covering a small area of infinity. So we can't know everything. Our tests can't tell us everything. And if we don't provide oracles, or if we don't provide good visualization of what the tests are doing, what the data is, where it is, what it means, then it's very easy for our stakeholders to wander off into, this area, especially. So you can have deterministic tests to the extent that you know what you are testing, and to the extent that you know what the known unknowns are. Deterministic tests are the only valuable kind of test. If a test isn't deterministic, then at best you have a crappy monitoring tool that's very expensive. Sometimes if your tests are non-deterministic, you can still throw them on a graph and learn something. But by default, if you have non-deterministic, expensive tests, then you're not really getting a whole lot of value out of testing. So oracles, I've come to understand, are actually the source of determinism. Because determinism, if you think about it, it means that the test follows one path, and it always follows the same path, and you know what it did. So the knowing what it did is actually provided by some kind of oracle, not by the test itself. The test is just a dumb piece of code that follows a path. There has to be some kind of metadata somewhere, usually just floating around in the minds of the team, about what does the test mean. In a way, I like to think of oracles like when you play pool or billiards. There's one form of the game where you call your shot. You say, okay, I'm going to put the 8 ball in the corner pocket, and then you do it or you don't do it. And I think that at best that's what test oracles are. It's simply saying the test is going to do X, Y, and Z, or the application under test will do X, Y, and Z, and then you do it, and you see if it did it or not, and you talk about it. This is in contrast to the style of testing that's especially popular around Selenium tests, it seems, where the tests run and then they require investigation. I've come to understand that tests that require investigation that's a red flag, an anti-pattern. Tests shouldn't require investigation. The application under test may require an enormous amount of investigation, but if you don't know what your tests are doing, what are you testing? So oracles at the end of the day are just this useful abstraction you can put on top of your already deterministic tests that provide meaning. So the subtitle of this talk was data visualization on the command line. That's maybe a better subtitle would have been getting at your data on the command line. Because actually I think today data visualization has become really easy. We have all of these fantastic tools that a lot of companies are already using. We have Grafana for arbitrary time series data, and Kibana and Splunk for logs. And we have, if you're into data science at all, we have the whole Python pandas and matplotlib and and then whole languages for data visualization. So what I found myself talking about is more how to get at the test data. So I hope that's cool. So, and I'm especially interested in command line tools because command line tools are automatable. GUI tools are neat. There's nothing wrong with using GUI tools, but if you want to expose data in an automatic way, and you're already using a CI server like Jenkins or Travis or something like that, then if you have an action that you're doing through a GUI tool, I'm not sure how you're going to get that into Jenkins other than using Selenium to automate the GUI tool, which is not, just like now it's like, somebody sent me like a GIF, like an infinite GIF of a Russian like nesting doll where you just keep opening it up and there's still one. Like that's what it's like Inception. So rather than, making this fragile pile of GUI tools, why not just do everything on the command line since you can? And so I'm going to talk about some of the data analysis tools that I use in my work. I'm going to talk a little bit about network analysis, and then I'm going to talk a bit about visual diffing and building dashboards off of Selenium screenshots. So in terms of data analysis tools, there's an enormous amount of power in the GNU Linux toolset. It was interesting to me when I learned that Linux, or rather Unix, was originally a text editing operating system. The original purpose of Unix back in the 1960s was to create textbooks. And those of you who've ever used LaTeX, like LaTeX Tech, those are some of the earliest Unix tools, and people use them to publish textbooks. So Linux and the GNU toolset have this fantastic power to process text. And in our world, where we're dealing with test output and test input, it's basically all text. So it's a really good fit. So these are some tools that I have grown to love. It was very hard to pare my list of tools down to just as many as I could talk about in 40 minutes. But okay, so first of all, curl. I'm sure curl is familiar to a lot of people because it's used for lots of different things, but I think curl is overlooked. For those of you not familiar, curl is a command line web browser. It retrieves any network resource. It can negotiate basic auth. It can negotiate OAuth if you want it to. It can receive and save cookies. It is capable of doing anything a browser can do, except for, of course, rendering JavaScript and CSS. Lynx is a funny one because Lynx was the first web browser. It's ancient, but Lynx has this little known functionality to act as a web scraper, and as such, it's incredibly powerful. For instance, if you just want to display some text from a Jenkins build page on the command line, Lynx can scrape that for you, and it can scrape it directly to text. You don't have to do any parsing. You don't have to write any code. And then these, the last two are really super interesting, and I could do a whole talk on each one. I realized last night as I was finishing the slides. XML Starlet is old. It's the basis of the Emacs mode that you use to work with XML, and it's probably buried in other XML tools that we've used over the years. What I did not realize about XML Starlet, though I'd used it in Emacs for years, is that it's actually a really powerful command line XSLT processor. But it does even more than process XSLT. It's basically the missing piece in the toolbox, or the missing tool in the toolbox, rather, for working with XML in a way that is not painful and insane. Now, you can work with XML by writing programs, right? Like Ruby has an XML module, and PHP has one, and every language has one, because you can't work with raw XML. It just can't, it's just horrible. You can't use regular expressions on it. You can't use any of your basic search tools on it. You have to parse it. XML Starlet removes all the programming language overhead and allows you to just get the data you need out of XML. And then JQ is a really fascinating new tool. It's only a couple of years old, but JQ is like a sed or an awk or a grep or for JSON. And since almost everything new is delivered in JSON and people are moving away from XML, JQ is, I think, going to be this really fantastic, life-changing tool. It certainly has been for me, that allows you to process JSON in very complex ways. Again, without the need for any programming language, you don't need to add another interpreter to your tool chain. So here are two incredibly powerful curl examples, so they may look simple. The first one grabs the Jenkins console log and scans it for some specific error text. This is a real-world example. Scanning for PHP fatals is good. There's all kinds of interesting edge cases in PHP unit tests where you can get a fatal but not necessarily fail your tests in the right place. So this is a big piece of Oracle's for me, actually, is scanning logs. Retrieve the log, scan it, run. In the real world, this regular expression would be like the whole slide. It would just be like, grep this, grep that, grep this other thing, like find this. Because when I started managing the Jenkins build at Etsy back 5 years ago, that was my life. Just people, IRC ping, test failed, what does it mean? And I would go through the log and scan and be like, so I just started building these tools that were like, this is what I used to call this the auto Noah. This is me reading the log for you. So while it's super simple, it's super powerful. And I think you'll find that's a theme with all of the tools that I really favor. The second example also doesn't look like much, but try it. It dumps the entirety of an HTTP transaction, or any network transaction. It doesn't have to be HTTP, but it's incredibly useful with HTTP because you can say, hit the application under test and find out exactly what is going back and forth between the server and the browser before the page is loaded. It's very similar to what Chrome Inspector does in the Net tab, but again, it's command line. So if you've ever wanted to take something you were doing in Chrome Inspector or Firebug or even Charles or any of these GUI tools that let you examine network traffic, and you wanted to dump it into the command line, this is one way to do it. So now let's talk about links. This is the magic with links. The dash dash dump argument. Dash dash dump turns links from a really ancient museum piece of a web browser to a really powerful web scraper. So this is a links implementation of a command line tool that just does a Google search, which is really simple and stupid unless you want to do a Google search from the command line for some reason and you don't have the tool. There actually aren't any working tools to do this that I could find unless you want to play with a programming language. The reason I'm so down on adding a programming language to your testing rig is the complexity. There's nothing wrong with programming, obviously. We all love programming. It's really cool. But again, when my first naive attempts to build this kind of stuff, I like Ruby, so I wrote everything in Ruby, and then it's like, now I have to install Ruby everywhere, and I have different versions of Ruby because I have, Chef uses Ruby, my tests use Ruby. There's all of these like resource contentions. So by just sticking with the command line tools, I cut out the resource contention. My developers, my team can use whatever platform they want. They can do whatever they want with LLVM and versions and stuff, and it's invisible to me. And I'm invisible to them, which is good. That's what infrastructure should be. It shouldn't get in the way. So again, a more practical use or more direct use for this is to scrape any of the numerous web assets that you have as part of your tool chain. If you want to scan for a particular error, check whether a page is ready to render, this is a great way to do it. And again, just note this is the text from Google. And all these two lines are doing is just cutting it so we don't have like a giant, like 500 lines of text here. All of the parsing is done with links internally. And this looks like a lot, but all it's actually doing is escaping URL escaping the argument, which is optional. It's just like if you want Google search to handle spaces and apostrophes and stuff like that, you need to escape it. If you don't, then you don't. So here's a simple example of using XML starlet. I had a project when I was a consultant a couple of years ago where I had some teams are still on SVN, sadly. And the SVN log isn't regular and pretty like the Git log. It's sort of, arcane. But fortunately, you can dump it as XML, and that's sort of how it goes, right? When we deal with these older tools, it's like they're ugly, the output is hard, but hey, you can dump it as XML. That's great. Now, what do I do with like 2 gigabytes of XML? So one fantastic thing about XML Starlet and JQ both is that they're line processors like awk or grep. They do not suck the entire document in and then process it. So you can actually deal with a really enormous, ridiculous amount of XML. If you have a gigabyte file, you can process it. that's great because XML, as we all know, is a really bloated format and it gets really big. And then here's an example of JQ, just very simple, but it should give you a sense of the power. JQ again is something I could give a whole talk on. It's actually a functional programming language, a very simple functional programming language, but that's what's going on here. It uses pipes, much like just like Bash. And what I'm doing here is post-processing a JSON time series that I got from Graphite. So Graphite is a RRD tool. It's a time series database, and it, when you pull the data out of it, it's represented as a big array with timestamps and then metrics. And especially when you're monitoring tests, you usually have a lot of timestamps where nothing happened because we're not running all the tests 24/7. So generally, you just want to ignore the places where nothing happened and look at the timestamps that have interesting data. And if you're pulling like a week of, say, your CI server data or particular test suite, it's going to be in 10-second increments, and most of those are going to be null. So it's a real pain to work with. You can simply filter it out like this. So the takeaway here should be that whatever format you're getting your data in, but especially if it's one of these more difficult to work with formats like JSON or XML, you can have it as plain text. You can have it as a different document in the same format. You can have it as a different document in a different format. And you can do it on the command line, which means that, again, that you can, once you work out your extract, transform, load pipeline, so to speak, once you work that out, you can drop it right back into Jenkins. And it becomes part of your tool chain. It becomes an oracle. I think I have to speed up a little bit. So there's two really powerful tools that I learned about from my ops team. One of Nmap, which is neat, and I recommend trying it out, and Netcat, or NC, which I absolutely cannot live without and is an essential part of my tool chain. It's notable that these are black box testing tools. These tools allow you to analyze hosts without having access to the host. I think that that's important for testers because often we don't necessarily have access to every host that we're responsible for testing. And just a caveat, before you do any network poking at your company or anywhere, just give a heads up to your security team that you're going to be scanning the network. It's interesting to reflect that Selenium test and a DDoS are the same tool chain, they're just used differently. So by the same token, a network scan and a malicious penetration attack, there is the same tool. So to a dumb scanner, it looks like the same thing. Nmap does this, which is a thing that I always wanted when I was first doing Selenium testing. Just show me what ports are open on the damn machine, right? I don't have access to the machine, so I can't run netstat. I just want to see, like, is the Selenium server up? So this would be a super simple way to say, no, the Selenium server is not up. This is why my tests are not working. A more subtle use of this would be, so for instance, in Java Web Services, there's all these little different services that run on different ports and they're on different hosts and they all have to be working in order for the test to work. So, without a tool like Nmap, it's possible to spend a bunch of time churning on a page and arguing with the developer about whether it's really broken or whatever, and then later you find out that, like, no, part of the CSS wasn't there because part of the service that serves the CSS wasn't actually up. And that's actually how I got into using these tools is I worked with some really smart developers on a Java project, but they were always, they just like, they were very reluctant to admit the possibility that maybe like their services were not fully serving everything, and that's why problems were happening. So being able to go back and prove that to them was really useful. This is the thing that I use Netcat for the most. This can save you a ton of time in your testing, just being able to pull for the Selenium server's upness and wait for it. And now let me go on to the final part because I'm running out of time. So this is the extract, transform, load pipeline that I typically build. Jenkins is really happy to hand you all the artifacts from your test suite. And then if you want to make sense out of them, you need to write some scripts to post-process them. And then ideally, you display them on a dashboard, put that up on a wall, and your whole team can look at the dashboard and make sense of the tests, even people who are not familiar with the tests. And I think this is one of the grails of Selenium testing, is making the results of the Selenium tests accessible to people who have no idea about the specifics of the test. So here's one way of doing that. This dashboard presents just the screenshot result for the same test step, for the same test, but across many, many different test environments. So each screenshot here is a different environment, and these are actually live production environments. This was for a company called Press Plus that I worked for a couple of years ago. And what Press Plus did was a paywall, and our paywall was installed on 600 plus different sites. So for QA to test that was, manually was really painful. And actually not even possible, because it's just too much work. So you can see some of these have a pop-up, and some of these don't. So this is just a little piece of the dashboard. It was much larger than this, and it allowed, it's pretty easy to visually distinguish that from these. So this allowed QA to just quickly scroll through a dashboard and say, okay, the light box is where the paywall is working there, it's not working there, it's not working there. Here's a more recent attempt where I'm using Imagemagick to visually diff screenshots from the same step, same test, but different builds. So this, I feel, really affords even non-technical stakeholders to make judgments about what changed, what was meant to change. So what this is doing here, and this is pretty easy behavior to get with Imagemagick, is the dimmed out areas didn't change between the two test runs, and the bright areas did change. So so this is, here you can see, maybe a little hard to see, but this is a case where the first time we got a normal web page, the second time we got a login form. So you can see there's like a bright page superimposed over a dim page. You can tell so that means you got two totally different results on each run. And with a little training, I think this is accessible even to like a project manager or an executive could read that and say, hey, what's up with the test there? And that's a great thing. All right, so let's look quickly at how I got that information together. So I'm using Codeception, which is a PHP framework. It's basically just a test runner like any other test runner. It's just new and nice. One of the things that Codeception does is automatically wrap all of your Selenium commands with a little function that also takes a screenshot. So like Sauce Labs, or like a lot of other services, you get a screenshot of every step of the test, and that puts you in a nice position to be able to diff two different runs against each other because you have the same number of screenshots and they're the same pages, and you just need to diff them. So I'm using Perl to dig this ID out of the log file. This is a great example of building an oracle because there's actually because the framework is new and the plugin is new, right now there's actually no way to get this ID programmatically. It's only printed in the log file. It's not actually accessible programmatically. So I'm going to write a patch and submit it back and all that, but that takes time and I needed to get this done. This is, again, this Perl-LWNE. This gives you the full power of the Perl language right on the command line. If you've used awk, it's like awk, but with a full programming language behind it. So this allows me to extract the ID of the test run. And then this is the entirety of the code for diffing the two images. So the idea is that the old would be stored by Jenkins somewhere in a known place where the previous test run was, and then this comparison image would be pulled out of the directory that I discovered by grepping out the ID with Perl. Compare is part of the Imagemagick suite. It's just a command line tool that you install, and it does visual diffing. So I realize that there's all kinds of super sophisticated stuff out there, that there's like whole teams of really smart people building visual testing tools with all kinds of artificial intelligence and smarts. But Imagemagick is a way to have maybe like 80% of that value for yourself just on the command line. So here's something I think is really nice. This is an example of what the diff looks like when the footer went away. So you can see here the footer is highlighted in red. The rest of the page is grayed out. And I think, again, I think it would just be a matter of telling the team, if it shows up in red, it's missing. And then you can put these thumbnails up on the wall and you have a really powerful test oracle derived from potentially really complex Selenium tests that anyone can understand. This is what the code looked like to create not just that diff, but a whole set of diffs from two different codeception runs. As you can see, it's really small. I'll just step through it really quickly because I know I'm running out of time. This is just plumbing. It just creates the directory. This is a bash for loop. I'm using the seek command to create to count from 0 to 9. And then these lines actually are just setting up the file names because codeception names the files, 000, 001. So this creates those names and interpolates them into the files, and then I'm running that same compare command. And then I'm reusing the index HTML file that codeception creates when it gives you the screenshots. Since I don't change the names, I can just reuse what codeception gave me. And I think this is a technique you'll see me use a lot, is like somebody else provided something I can use. If I just if I just follow their naming convention, I'll use that. I'm not going to take the time to create my own, because why? So again, here you can see, actually this is maybe a better version of the page where, the first time the test was able to log in because we see a full page. The second time the test got stuck on the login because that's what we see there. And I think that that's a situation that's really, really hard for even a seasoned developer that's really hard for them to figure out from looking at the Selenium logs. That's a case where somebody would probably come to me or somebody on the test team and say, like, what's going on? It looks like the test worked, but blah, blah, blah. So this, I think, is really clear. So in conclusion, oracles are basically, as I think of them in this context, oracles are basically alerting without the alerts. Rather than trying to create some kind of, basically some kind of machine learning system that would be capable of making statements about those changes, we simply display the changes visually. We visualize the changes in a way that a human can make decisions about them, because ultimately that is what has to happen at the end of any test run, no matter how much machine learning is in place. Ultimately, a human has to make the decision. So my philosophy over time has become, like, concentrate less on the machine learning part and just concentrate more on getting that information in front of the human in the most consumable way possible. So that was the talk. I hope you enjoyed it. We have, I think, exactly 10 minutes for questions. And hopefully there are some questions. Oh, thanks. Yep. And I saw somebody's hand over there. No? Oh.
Hi. First of all, thanks for an interesting talk. I wanted to ask you, you showed us a lot of cool stuff, lots of small programs which do very useful things. What is the place for those all those programs? Do you run them before a suite of tests, or during test execution, or in the end when you need to analyze some failures?
That's a great question. So where do you run the tests? Where do you use this code? A lot of the time where these kinds of code snippets will wind up is in the post-build action on Jenkins. So I think this is true for any CI server, but after the build is done and when you're running the post-build step, the whole log is available. So you can run all kinds of scans on the log using these tools, and then you can use the feedback from those scans to affect the build status. So I showed a scan in there that was like finding a PHP fatal in the log. I would put that in a post-build step and say, okay, even though this build passed, we somehow got a fatal in there, so fail it. Another really useful thing to do, especially for Selenium tests, is to put some checks in there so that you can pass the build, even if even if you didn't get like the passing status. A lot of this stuff is stuff that I'll use personally on the command line to answer, just on my laptop, to answer questions that people are asking me. That's how a lot of this came about. And then I guess a final way that I'll use it is just set it up as its own Jenkins job, like retrieving like 10 days of log files and scan them, and then pull some information out, and I'll send that to Graphite and make unfortunately, I didn't fit into the deck, but we have a graph at Teachers Pay Teachers right now that shows the amount of coverage just on the models directory in our PHP project, for instance, or the number of times that somebody violated the coding standard by trying to introduce a long method into a controller. So I do a lot of sort of one-off coding of things like that, where those are actually Jenkins jobs that are just pulling from other Jenkins jobs, post-processing the log, and then putting it somewhere else where people can see it.
And the following question, now that you have all the results of that additional processing, how do you present that result? Where do you store it, and how do you show it to other people?
I use a tool called Graphite, or Grafana. Actually, at Teachers Pay Teachers, I was introduced to Grafana, and I like that a lot. So if it's a time series, then Graphite or Grafana are great for that. If it's not a time series, then actually what I'll do is just try to get creative with some jQuery. And one thing that can be really useful is to just print out the information in human readable language and put it up on the wall. I had a dashboard at Etsy for a long time that just said, like there were 75 commits today and 35 of them included a unit test. And that's actually what I just said, that's what the dashboard would say verbatim. It was just a bunch of like headlines, almost like I look at how newspapers display this stuff a lot, or like how the New York Times will display headlines, and I try to follow that. I think that's what's really fascinating about working with the data this way, is it's sort of open-ended.
Thank you.
No, thank you. Yep.
Can you point to this tool that you were talking about?
Oh, Grafana? Yeah, sure. Let's see if I can. I'll just, I'm just going to put that name up just so you can see it. But. So that's the name of the tool. It's actually, there's two different tools. Grafana is a pretty front end for graphite. And also Grafana is easier to Google. When you Google graphite, you get a lot of stuff about pencils. I think, do I have time for another question, or are we out of time? Nope. Okay. I think that's it for the time anyway. All right. Well, thanks a lot.